Hello guys, and welcome back to the reaction zone. In today's lesson, we're going to look at the concept of polar covalent bonding. A polar covalent bond is a bond that is formed between two atoms in which there is an unequal sharing of the bonding electrons. This unequal sharing of the bonding electrons is as a result of the fact that the bonding atoms have different electronegativities. And this unequal sharing of the bonding electrons in a polar covalent bond results in the formation of a partial positive charge on the less electronegative atom and a partial negative charge on the more electronegative atom. So what this means is that the unequal sharing of the bonding electrons results in the formation of a dipole in a compound that is formed by polar covalent bonding. In polar covalent bonding, the difference in electronegativity of the two bonding atoms is very important. Usually, atoms that will chemically combine and form polar covalent bonds are atoms whose difference in electronegativity values ranges from 0.5 to 1.5. Here we see examples of compounds formed by polar covalent bonding. The first example here is hydrogen chloride. In the formation of hydrogen chloride, one hydrogen atom combines with one chlorine atom to give us hydrogen chloride. Hydrogen has a covalency of 1. Chlorine has a valency of 7, that is 7 electrons in its outermost electron shell, but has a covalency of 1, meaning that it only has one unpaired electron in its outermost electron shell. So, each of these atoms donates 1 electron each for forming this bond. And the structure of hydrogen chloride is what is shown here. The bonding electrons is what we have here. These bonding electrons is not shared equally between this hydrogen atom and this chlorine atom. And the reason is simple. The reason is because chlorine has a greater electronegativity value than hydrogen. So meaning that the chlorine atom will strongly attract this electron pair to itself than this hydrogen atom. As a result of that, the chlorine atom will have a partial negative charge and the hydrogen atom will have a partial positive charge. The second example is water. In water, one oxygen atom is combining with 2 hydrogen atoms to give us 1 molecule of water. Water has a covalency of 2. Each of the hydrogen atoms has a covalency of 1. When they chemically combine, you get the structure of water. In water, there are 2 OH bonds. This is one, this is another. Each of these OH bonds is a polar covalent bond. Oxygen has a larger electronegativity value than hydrogen. As a result of that, the electron pair in each of these OH bonds is not shared equally between the oxygen atom and the hydrogen atoms. The unequal sharing of the electron pair in each OH bond results in the oxygen atom having a partial negative charge and the hydrogen atoms having partial positive charges. The third is ammonia. In ammonia, 3 hydrogen atoms combine with 1 nitrogen atom to give us ammonia. Nitrogen has a covalency of 3, but has 5 electrons in its valence electron shell. Each of the hydrogen atoms has a covalency of 1. So, it means that 3 hydrogen atoms will combine with 1 nitrogen atom to give us this structure of ammonia here. In ammonia, there are 3 NH bonds. This is one, this is another one, this is another one. Each of these NH bonds in ammonia is polar covalent. Nitrogen has a greater electronegativity than hydrogen. So, as a result of the electronegativity difference between nitrogen atom and the hydrogen atoms, the electron pair in each NH bond will be strongly attracted towards the nitrogen atom than the hydrogen atoms. As a result of that is, due to the unequal sharing of the electron pair in each NH bond, the nitrogen atom is going to have a partial negative charge, and each of the hydrogen atoms in each NH bond will have a partial positive charge. Here, let's look at the importance of polar covalent molecules. Polar covalent substances dissolve in water and other polar solvents. This is because like dissolves like. Polar solvents will dissolve polar compounds. Non-polar solvents will dissolve non-polar compounds. The second one is that polar covalent molecules can be transported in blood plasma. It is important for us to know that plasma is the free component of blood. And plasma is 90% water, meaning that plasma is composed mainly of water, and water is polar covalent. So, polar covalent molecules like glucose can be transported in blood plasma because blood plasma is largely made up of water. I want to believe that this explanation of the concept polar covalent bonding is clear. Thank you for watching and see you in the next one.